Welcome back to Agent Mode AI. This is Kim.
And I'm Darren. We're thrilled to have you join us again for episode 6.
Last time, in episode 5, we really dove into the exciting world of agents using tools to take real-world action. We explored how these AI systems move beyond just generating text to actually interacting with external APIs, databases, and even web interfaces to get things done.
Exactly. From fetching real-time data to managing your calendar or even drafting complex emails, agents equipped with tools are transforming how we interact with technology. It was all about making AI truly actionable.
And today, we're taking that a step further. We're moving from agents that execute to agents that evolve. Our topic for episode 6 is Agents That Learn, the rise of self-improving AI workflows.
This episode is all about how agentic AI systems can adapt and evolve based on feedback, outcomes, and their own performance. We're talking about moving from fixed instructions to truly intelligent refinement.
So what exactly does self-improvement mean for an AI agent? It's not just about an agent executing a set of instructions. It's about an agent being able to evaluate its own output, learn from its successes and failures, and then update its behavior accordingly.
Think about it like this. A human worker learns from experience, right? An AI agent can do the same through what we call feedback loops. This involves self-reflection, where the agent critically examines its own work, and prompt iteration, where it modifies its internal instructions or approach based on what it has learned.
It's a continuous cycle. Act, observe, evaluate, adapt, then act again. This iterative process is key to building agents that become more effective over time without constant human intervention.
So, how does this self-improvement actually work in practice? One common method is agents scoring their own outputs. An agent might generate a response, then use an internal rubric or even another LLM to assess the quality, relevance, or adherence to the task.
These evaluations can then be tied to reward signals. These could be explicit metrics like engagement rates if it's a content agent, or more internal evaluation scores against specific criteria. Based on these signals, the agent can make various adjustments.
This might involve subtle prompt tweaks, updating its internal memory or knowledge base with new information, or even shifting its overall strategy for tackling a problem. Imagine an agent realizing a certain approach consistently leads to better outcomes and then prioritizing that approach.
And it gets even more meta. We're seeing the emergence of meta agents, agents designed specifically to review and optimize the performance of other agents. They act like an AI quality assurance team, constantly looking for ways to improve the system as a whole.
We're not talking about purely theoretical concepts here. There are real-world frameworks emerging that support this kind of self-improvement. For instance, AutoGen, from Microsoft, has a self-reflection module that allows agents to critique their own code or responses.
SuperAGI leverages feedback-based memory, meaning agents can store and recall past interactions and their outcomes, using that data to inform future decisions. And LangChain offers powerful LLM evaluation tools that let you programmatically assess an agent's performance.
We're also seeing this integrated into common patterns like React combined with RAG, or Retrieval Augmented Generation. Agents can generate a response, retrieve relevant information, then iteratively refine their answer based on a scoring mechanism, leading to much more accurate and comprehensive outputs.
Let's think about a practical use case. Imagine an AI writer and editor agent. Initially, it might have a general set of instructions for creating blog posts, but with self-improvement capabilities, it could analyze the performance of past content and generate it.
It might look at engagement metrics, bounce rates, or even qualitative human feedback. If it notices that articles with a more conversational tone perform better, it can adapt its style. Or if short, bulleted lists get more reads than long paragraphs, it can adjust its formatting strategy for future pieces.
This isn't just about minor tweaks. Over time, this agent could develop a highly optimized tone, structure, and content strategy perfectly suited to its target audience, all based on its own iterative learning without explicit, constant human programming. That's the power of agents that learn.
Now, As exciting as this is, it's crucial to address some warnings and caveats. One major risk is hallucinated self-evaluation. An agent might confidently score its own poor output as excellent, leading it down a path of reinforcing ineffective or even incorrect behaviors.
This highlights the critical importance of well-structured and reliable feedback. If the scoring mechanism isn't robust, or the feedback loops are based on flawed data, the agent could end up reinforcing poor outputs instead of improving them. Garbage in, garbage out, as they say.
So, while the potential is immense, designing these feedback loops and evaluation mechanisms requires careful thought and often initial human oversight to ensure the agent is learning the right lessons.
Absolutely. The journey towards truly self-improving AI is just beginning, and understanding these concepts is key to building more resilient and intelligent agent systems.
And that brings us to the end of episode 6 of Agent Mode AI. We hope this exploration of self-improving agents has sparked your creativity and given you some practical insights.
Your call to action for this week: try to build a tiny feedback loop into one of your agents. It doesn't have to be complex. Even a simple self-correction mechanism based on a clear rule can make a huge difference.
Join us tomorrow for episode 7, where we'll be discussing agents on autopilot, how to schedule and sustain your AI workflows. You won't want to miss it.
Thanks for tuning in to Agent Mode AI.
We'll catch you next time.